Welcome to LNP Renewable System Limited. Today we are going to discuss some of the basics of electric vehicle part 17. If you have missed part 1 to 16, no issue. Please subscribe to the channel. In our channel we had created the playlist. So in the playlist you can see all the things that we had discussed related to the electric vehicle. Okay. So in our discussions we might be using so many short forms and abbreviations. So if you have any doubt in those, kindly refer to this part. So what are the things that we are going to discuss in this part today? First thing is that we are trying to learn how to calculate the number of cells needed for a battery in an electric vehicle, and also we are going to calculate the pack energy and the capacity for a battery in an electric vehicle. Okay, and we are trying to sort out what is C rate of a battery, okay, which is being used in the electric vehicles, and what are the factors which affects a thermal management system in an electric vehicle, and how a battery charge rate is affected by a temperature in an electric vehicle, and what are the functions of the thermal management system in the electric vehicle, and how a thermal losses are controlled using a thermal management system in a control unit in the electric vehicle. So first let us try to know how to calculate the number of cells needed. Say for example, if we know the voltage of the entire pack and if we know the voltage of the individual single cells, then we can try to sort out how many number of cells that we need for designing a battery. Say for example, that is, we need to divide the entire pack divided by the single cell. Say for example, if we need 100 watts and your individual cells is capable of providing 10 volt. Okay, I'm just telling an example. Okay, so your entire pack voltage is 100 voltage or a 200 voltage. Okay, and your individual cells are capable of providing 10 volt output. Then 200 divided by 10, it will be 20. So it means you need 20 number of cells. So with the help of a voltage of the entire pack, we can able to sort it out. We can able to know the motor design requirement. Okay, and this individual single cells we can able to know through the cell chemistry combinations. We can sort it out the single cell voltages also. Okay, so here is an example here. See here, the entire voltage that we plan, okay, for the battery to prepare. Say for example, lithium nickel manganese cobalt oxide. Okay, let us consider the pack voltage is 360. Okay, and the individual voltage per cell is 3.6. So it means 360 divided by 3.6. It means we need 100 number of cells in series to create this battery pack. In the same example, okay, if you try to know the lithium ferrophosphate battery individual voltage per cell, if you know the pack voltage, for example, is 360, so 360 divided by 3.2, it means we need around 112 to 114 total number of cells in series. Always, if it is coming in point values, no issue. Always try to take a whole number either in the even or in the odd. Okay. Even for the lithium titanium also, 360 divided by 2.2, it might be 162. If it is coming in the point, then you can add, keep the cells in either even or the odd formats. Okay. And if you want to calculate the pack energy and the capacity, first we need to know the energy of the pack, and we also need to know the capacity of the pack. So the energy of the pack is nothing but the motor continuous current requirement. Okay, and whereas IP here refers to the motor peak current requirement. So if you know it, then we can able to calculate the energy of the pack, because see here, if you want to calculate the energy of the pack, we need to know the voltage of the pack and also we need to know the capacity of the pack. So this voltage of the pack, using our previous formula, we can able to sort it out, and this IP we already know, because what is the most motor peak current requirement. Using that we can able to sort it out the energy of the pack required. So this is an example here. So as we told earlier, we know the pack voltage, that is 360. Okay, and also we know the total number of cells in parallel. Okay, and we also know the capacity per cell also in AH, and also we also know the voltage per cell values also. Okay, So then when we discuss the energy storage system, C rating is very much important. What is the C rating? It is nothing but a unit, okay, which often battery experts used to use, because it is used to measure speed at which the battery or individual cell is getting charged and the speed at which it is getting discharged. Say for example, see here, if you draw a waveform between a voltage and a discharge capacity, okay, in mAh. See here, so this is an example. It is charging at 0.5 C maximum, that is 4 to 20 volt, okay, and 65 mAh cutoff at 25 degrees Celsius. Whereas in case of discharge, it is happening at 2.5 volt cutoff at 25 degrees Celsius. Means it is charging at a very fast rate and it is discharging gradually. Okay, this is the meaning of it. Okay, and here also it is charging at 0.7 C maximum. Okay, whereas in case of discharging, it is at discharging at the rate 2.5 volt. It's an example of a 48 volt cube, that is 75 Ah lithium ion fixed battery, which we often used in our vehicle applications. And if we get into the specification, cell technology is very much important. What will be the cathode, what will be the anode, and what is its nominal capacity, and also we need to know the voltage. What is the minimum voltage, what is the nominal voltage, and what will be the maximum voltage. Okay, and also we need to know the charge and the discharge C factors, because continuously it means it will charge at 2 C, whereas discharge it is continuously in 3 C. Okay, and if you're going for a pulses, for charging it will be at 4 C, and for discharge it will be at 10 C. So if we try to know the entire life cycle of these batteries, it will be up to 600 cycles. And what are the factors which affects the thermal management system? So a battery pack thermal management system will be affected by the operating environment. At what environment we are going to keep our batteries. Okay, second thing is that its duty cycle, and third most important thing is that cell chemistry and the type. Okay, and when we try to draw a waveform between a charge rate and the temperature of a lithium battery, see here, at a minimum temperature, okay, the charge rate is more. As the temperature increases, see here at 70 degrees it is charging at 3 C rate. Okay, but when we increase the temperature, it is getting reduced. It means the charging capacity is getting reduced from 3 C to 2 C. Okay, as we keep on increasing the temperature, what is happening? The charging rate is getting reduced. It means temperature plays important role. Okay, it is charging rate is highly affected by the temperature. And what are the functions of a thermal management system? Very simple. In order to maintain a temperature difference of about 2 to 3 degrees Celsius, okay, from the coolest cell to warm cell, we are using this thermal management system. Okay, and when the cells are very hot, okay, it will age faster than the cooler cells. Okay, so it means the battery calendar life will get reduced because of the highest temperatures. And when we try to sort out a control diagram of a thermal management system for a hybrid electric vehicle and electric vehicle, this is how it looks like. Because most importantly, we need to have a cabin for the evaporator, and we need to have a chiller, we need to have air compressors, and we used to have a air separators, and we used to have a air radiator. Inside the cabin evaporator, we will have a HVAC module. Okay, and also we will have a high voltage electrical vehicle battery pack. So a coolant pump is there, so it will try to take the cooled air from the AC condensers, and it is trying to supply to the cool temperature to the hybrid electric vehicle batteries. Okay, and the hot air is taken out and it will be given to the chillers, and it will be again recirculated to the radiators also. So most importantly, on the AC compressor side, we have a high side refrigerant pressure sensor and we have a low side refrigerant pressure sensor. Okay, so what will happen? So with the help of compressors, we are utilizing the heat energy which is required for us, and with the help of a chillers we are cooling down the hot air to the cold one. Okay, and for circulating purpose we are using the coolant pumps. Even in certain places, if it is too much cold, then we need heaters also, so we are keeping the heaters there also. Thank you so much. Please subscribe and press the bell icon. If you want to know more and learn more, you can contact us. We have provided the contact details here. We are also providing PLC programming training along with the certification ISO 9000 2018 certification for Siemens, Hallenberg and Delta PLCs. And if you had a plan to work in the GCC countries, we are also providing training in building management system and the building automation control system. And if you had a plan to establish a diesel IT system where the EV power is not available, then you can contact us. We are providing design, installation, testing, commissioning, consultancy supports also. And for solar on-grid and off-grid and hybrid application, street lights and solar pump services, we are providing installation, testing and commissioning, consultancy, training supports. And if you had a plan to put the fencing for your agriculture farms, we are also providing solar fencing as a kit. Okay. And if you had a plan to learn the basics of the electric vehicles or the access control system, then you can contact us. We are providing the contact details here. Thank you so much.